Hello there, Mr. Sutton here, bringing you the IM3 Honors 5-3 Extra Practice Number 4 solutions on Rational Roots Theorem. For this one, there's a puzzle. Let's check that out. So for this puzzle, we're trying to figure out what you get when you cross a lion with a camel. We've got all these polynomials down here. There's a total of 8. And for each of these, they've given you one of the answers. In this case, number 8, they gave you 4 is one of the roots. You have to use that to find the other roots. Once you find them, over on this column on the right here, whatever letter is next to those roots, you're going to put that letter above the problem number down in these blanks below here. So let's go ahead and see what we get out of this. So here we go with problem number 1. We've got x cubed minus 3x squared minus 10x plus 24, and they're telling us 2 is one of the answers. My strategy on all these problems is going to be the same in the beginning. I'm going to use whatever they gave me as the box number with synthetic division on the polynomial, and whatever I get when I do that, I'm going to get a quotient. I'm going to use that quotient to figure out the remaining roots. Now, what I do when I get to that quotient, sometimes I might factor, sometimes I might have to go quadratic formula, so we'll figure it out when we get there, but we're starting the same way each time. So for this first one, I've got 2. Let me write out my synthetic division coefficients here. So we've got 1, negative 3, negative 10, and 24, box number of 2. So I bring down my 1, there's my box number, bring down the 1, and then 2 times the 1, that's giving me a 2 up here. Now I'm adding these top 2 rows, so negative 3 plus 2 is negative 1, times 2 gives me negative 2 over here, plus negative 10 is negative 12, times 2 is negative 24, plus 24 gives me 0. I should get 0 every time I start one of these problems because they've given me one of the zeros, one of the things that gives you 0 when you plug it in here. So I have x minus 2 then as one of the factors I can split this into, and the other factor is going to be the quotient of this thing, which is always going to be found by using these coefficients down here, starting one exponent lower than the original problem. So this 1 here represents a 1x squared. This negative 1 is really negative 1x to the first power, and this negative 12 is just negative 12. So next up, I'm going to go ahead and factor the x squared minus x minus 12. So I still have the x minus 2 that I can bring down if I want. But now splitting this up, I need things that multiply to negative 3, or negative 12 rather, and add up to negative 1. So that would be positive 3 and negative 4, multiplies to negative 12, adds up to negative 1. So I'm going to write x plus 3 and x minus 4. And then setting each of these equal to 0 and solving, for this first one I get 2, which is no surprise because they gave that one to me, and then negative 3, and then finally positive 4. So we're just finding the remaining roots, so I'm not going to see this 2 listed in the answers, but I will be looking for the negative 3 and the 4. Negative 3 and 4, I see that, let's see here, where is it? Right here. This is going to be letter O, so that's what goes in spot number 1. So here we go now with problem number 2. We'll start it the same way as number 1, synthetic division using negative 1 as our box number. So my coefficients, we've got 2, negative 9, negative 6, positive 5, box number of negative 1. Bring down the 2. We have negative 1 times 2 is negative 2, plus negative 9 is negative 11. Times negative 1 is going to be 11, plus negative 6 is 5, times negative 1 is negative 5, and then that adds up predictably to 0. So I've got x minus minus 1, or x plus 1, is one of the factors I could break this into. And then I've got 2x squared minus 11x plus 5. So I'm going to have to use either quadratic formula or AC method to figure out this 2x squared minus 11x plus 5. I'm going to go with AC method here. So my AC value is going to be 2 times 5, or 10. So I can split this up. Two things that multiply to 10 and add up to negative 11. 1 and 10 works if they're both negative. So I can write this as 2x squared minus 1x minus 10x plus 5. I'm not going to worry about bringing down this x plus 1 just yet. I'll do that at the very end once I've got this fully factored. So now I can now we're going to do factoring by grouping since there's 4 terms. So for common factors, I can take an x out of the first two. That leaves me with a 2x minus 1 inside there. For the last two, I can take out a negative 5, leaving me with a 2x and a minus 1. So when I factor all this out, I've got the x plus 1 I started with. This 2x minus 1 is coming out as a common factor. And then the leftovers, x minus 5, go back in as my final factor. Setting these each equal to 0 and solving, this initial one gives me the negative 1 that they started me with. And then 2x minus 1 equaling 0. I'm going to add 1 and divide by 2 to get 1/2 for that one. And then finally, 5 minus 5 is 0, so that's my last 0. So for my answers, I'm looking for 1/2 and 5 in the answer choices. That's right here, letter L. So I'm going to take the L in a good way, and we're going to put it on the 2 here. For this next problem, we've got another polynomial. Let me start off with my synthetic division. So we got 3, negative 19, 22, and 24. Box number of 3. Bring down that first 3. 3 times this 3 gives us 9, plus negative 19 is negative 10, times 3 is negative 30, plus 22, we've got negative 8, times 3 is negative 24, which adds up with 24 to give me the 0. So we had x minus 3, and then 3x squared minus 10x minus 8 equals 0. Again, I'm going to use my AC method on this. So 3 times 8, that's going to give me negative 24 for my AC value. So I'm looking for things that multiply to negative 24 and add up to negative 10. Let me think. 1 and 24 doesn't work. 2 and 12 could work if I had positive 2 and negative 12. So let me split this up. 3x squared plus 2x minus 12x minus 8. For my first two terms, I can take out an x. Leaves me with 3x plus 2. Next two terms, I can take out a negative 4, leaving me with a 3x and a plus 2. So factoring all this out, we've got the x minus 3 that we brought down from before. We have the 3x plus 2 common factor that we can take out of this stuff. And then we have the x minus 4 also left over. Going through and setting these equal to 0, we have x equals 3 for that first one. For this next one, we subtract 2 and divide by 3, so negative 2/3. And then finally, we have 4 for this last parentheses. So my answers I'm looking for, negative 2/3 and 4. I see that right here next to E, so let's put that in spot 3. This next problem has a little bit of a twist to it. So we have another polynomial, but this time our box number is a fraction, which seems kind of weird, but we'll deal with it. So we got my coefficients. We have 4, 7, negative 62, and 15. Box number, again, is a positive 1/4. So bring down that 4 in the beginning. Now we have 1/4 times 4. So 4 divided by 4 gives me 1, plus 7 is 8. 1/4 times 8, 1/4 of 8 is going to be 2, plus negative 62 is negative 60. 1/4 of negative 60 is negative 15, plus the 15 gives us 0. So I have x minus 1/4, which again seems kind of weird, but we're just going to roll with it. And then we also have 4x squared plus 8x minus 60. All right, so one thing I can definitely do with this expression here before I run to the AC method is see if there's any common factors. Now 4, 8, and negative 60 are all divisible by 4. So I can take a 4 out of all of that, leaving me with x squared plus 2x minus 15. And I can factor that a little further. So I'm going to have the 4 that I just took out. I'm going to have this x minus 1/4 that I took out right in the beginning. And now for the stuff left in here, factors of negative 15 that add up to 2, 1 and 15 doesn't work. 3 and 5 does, negative 3 and positive 5. So I can break this up into x minus 3, x plus 5. All that equals 0. Going through and setting these all equal to 0 and solving, we have x equals 1/4, positive 3, and negative 5. The only ones that matter for my answer choices are 3 and negative 5. which I see right up here. This is a. U is very close, so be careful there. But we want negative 5, positive 3. So A is what I'm putting in spot 4. Next up, we got number 5. Let's write down our coefficients. So we got 1, negative 3, 4, and negative 12. Box number of 3. Now I'm going to do the problem using this method that I've been using for this whole puzzle, just for the sake of consistency. But I did want to point out that because you have a 1 to negative 3 ratio on the first two terms and also the second two terms, 4 to negative 12 is really 1 to negative 3, you actually could use factoring by grouping right away on this thing and probably get the answer a bit faster than I'm about to. But here's my version of the answer. So let's bring down our 1. 3 times that is going to be 3, plus negative 3 is going to be 0, times 3 is still 0, plus 4 is 4, times 3 is 12, and then we have another 0 over there. So I have an x minus 3, I have a x squared, and there's a 0 here, so I don't write an x term. This is 0x, but I don't need to write that. And then plus 4. So the x squared plus 4 part, I can solve that pretty quickly. I've got the 3 from the x minus 3 that they gave me right away, but I can also set x squared equal to negative 4 to zero out this parentheses. And if x squared equals negative 4, I can square root both sides. I just have to remember a plus and minus when I do that. And also, since I'm taking the square root of a negative, I'm going to have an I. So instead of getting plus or minus 2, I get plus or minus 2i. So my answer is 2i and negative 2i. I see that ironically or poetically maybe under choice I right here. So I'm going to put an I next to 5. So most of these problems that we've been seeing on this puzzle have been different in some special kind of way every time you move forward one problem. This one's no exception. This time we're getting an extra special box number here. Like we dealt with 1/4 before, but negative 5 over 3 is considerably stranger to deal with still. So let me write my coefficients. We've got 3, negative 10, negative 13, and 20. Box number of negative 5/3, although I'd like other box numbers, but we'll take this one. So bring down that 3. Now to multiply over and over again by negative 5 over 3, what I'm going to be doing in my head is dividing the number down here by my denominator of 3 and then multiplying by negative 5. So 3 divided by 3 is 1 times negative 5 gives me negative 5 plus negative 10 is negative 15. Now negative 15 divided by 3 is negative 5 times the negative 5 in the numerator gives me 25. Plus negative 13 is going to be 12. 12 divided by 3 is 4. 4 times negative 5 is negative 20. And then negative 20 and 20 adds up to 0. So I've got x plus 5 over 3 for one of my factors that I could write. And then 3x squared minus 15x plus 12 equals 0. Now I see that 3, negative 15, and 12 are all divisible by 3. So I'm actually going to attack this by first taking a 3 out of all that, leaving me with x squared minus 5x plus 4. So I've got the 3 that I took out initially. I've got the x plus 5/3. And now I can factor the stuff inside here a little more. Things that multiply to 4 and add up to negative 5. 1 and 4 works if they're both negative. So I can write x minus 1 and x minus 4. Zeroing everything out, I get x equals negative 5/3, which I already had, x equals 1, and x equals 4. So let me look for 1 and 4. That's going to be m right there. So that's going to be 6 for m. So after doing number 6 and looking at 7, you might be getting a little suspicious. We just have an x cubed here, not like a 3 or 4x cubed. And our box number is surprisingly innocent looking, negative 2 versus like negative 5/3. So what gives, you might ask? Well, let's start doing this out and see what happens. So my first coefficient is 1. My next coefficient is not negative 8. This is the trickiness that they're adding to this one. There's some other things too, but this is the first bit of trickiness. I'm missing an x squared term. which means I need a placeholder 0 to hold that spot when I do my synthetic division. Then I've got the negative 8 because x to the first is after x squared. Then I have another negative 8. Box number is going to be negative 2, no surprise there. So we bring down our 1 times negative 2 is negative 2, plus 0 is negative 2, times negative 2 gives me 4, plus negative 8 is going to be negative 4, times negative 2 gives me positive 8, and all that adds up to 0. So I've got x plus 2, x squared, minus 2x, minus 4. And we have x equals negative 2 for that first one, which we already had. Now the rest of this is where we also kind of see an increase in the intensity, because if you're thinking of numbers that multiply to negative 4 and add up to negative 2, well, there's 1 and 4, negative 1 and 4, or 1 and negative 4. Neither of those is going to give you 2. 2 and negative 2 also doesn't add up to negative 2. So this actually cannot be done by factoring. We've got to use quadratic formula or completing the square. I'm going to go with quadratic formula. So we have x equals negative b, so negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1 in this case, times c, which is negative 4, all over 2 times a, which again, a was 1. So simplifying, we've got a positive 2 out there, plus or minus square root of, this is 4, and then minus 4 times 1 times minus 4 is a plus 16, all over 2. So this is a 20 inside that square root. Now the square root of 20, I can break that up into radical 4 and radical 5. Square root of 4 gives me a 2 radical 5 if I simplify that. And now I can divide each of these terms by 2 to get 1 plus or minus 1 radical 5. So 1 plus or minus radical 5 is this answer choice here, n, so that's going in spot 7. For my last problem, we have coefficients of 1, negative 10, 30, and negative 24, so no placeholder zeros to worry about on this one. Box number of 4. Bring down the 1. 4 times that is 4, plus negative 10 is negative 6, times 4 is negative 24, plus 30 is 6, times 4 is 24, plus negative 24 is 0. So that's x minus 4, and then we have x squared minus 6x plus 6. We have x equals 4 for that first one. And then for the rest of it here, things that multiply to 6 and add up to negative 6, 1 and 6 doesn't work, 2 and 3 doesn't work, nothing works, quadratic formula time. So we have x equals negative b, so negative 6, plus or minus square root of negative b squared, so negative 6 squared, minus 4 times a value of 1 times c value of 6, all over 2 times the a value 1. So this is going to be positive 6 plus or minus square root of 36 minus 24 all over 2. That's a 12 inside my square root. I can split up the square root of 12 into radical 4 and radical 3. Square root of 4 is 2, so this is really 2 radical 3 that I can write that radical 12 as. And then dividing each of these by 2, this is going to be 3 plus or minus 1 radical 3. And that's going to be answer choice C, so there we go. So now to solve this puzzle, what do you get when you cross a lion with a camel? You get a camel lion or chameleon. I guess it's supposed to be like a play on the words with chameleon, something that changes from one thing to another. There you have it. I'm going to change things that I'm doing at the moment here. Till next time, Mr. Sutton signing off.